Okay, all right. So today we're going to start something called residuals, which has everything to do with the line of best fit. Um, and the only way that I would describe it, it's a little bit like mean absolute deviation in the way it's set up because it's not a super popular question. It shows up, but the origin of it can be fairly complicated. So, okay, all right. So right now, what we're gonna do is this: you're going to watch the Khan Academy video that I've assigned. All right, it's 5 minutes long. Watch only the first 3 minutes, and then skip to my video. Okay, all right, let's do it. Okay, all right. So I'm gonna pick up where Sal Khan left off. All right, because his explanation was gonna be better explanation than mine. All right, only because the way he delivers it, it's a smoother delivery. And whereas I'm gonna say a lot of like and I think or right and all that stuff. So it's a better video. Okay, now I'm gonna pick up where he left off. So what he said at the end, right at the very end, was that a residual in this topic, right? Is the actual value of y minus the y value that's predicted from the graph. Because remember, all this has its origins in the line of best fit, right? It didn't say the most accurate fit, right? It says it's the best approximation. So anytime, so this was like the I forget what's it called, the error thing from 7th grade when you guys calculated that, right? It's the same thing, right? Relative and actual error, right? If you guys got around to that. So it's the same thing. A residual is just what you actually have minus what you predicted from the line of best fit itself, right? Now, imagine, right? Instead of plotting a table like over here, right? Instead of plotting a table like this with all the values, right, that we probably have done in class already, instead of plotting those values on the x and y axis, if you plot the points of the residuals themselves, meaning that after you subtracted the two numbers, that number, if you take that number, I'll just call it RES, okay? Because I don't know what's the appropriate letter for it. Let's say we plot all the residuals on a graph, right? One of the things I want you to pay attention is this. This is big. If you see a pattern in a residual plot, it means that the regression equation is not appropriate for the data. So it's a bad thing. Okay? It's bad. All right. You don't want to see a pattern because, again, what it means is that your equation is not that good. Okay. So when your equation is not very accurate to reflect the data, remember, this is a line of best fit, right? So if it's not a best fit, then it's not a good fit, right? So that means, again, if there's a pattern in the residual plot, that means your equation is not very good. Okay, so what do they look like, right? This. So is this a good? Is this a good? Is the equation good? Is the linear equation or the line of best fit? Is this good? Was this equation good? Yeah, because there's no pattern, right? What about this one? No good. There's a pattern here. It forms a shape. This one, good. This one, really not good, right? So that's what that means. Okay, again, if the residuals form no patterns, they're good because what it's saying is your line of best fit already taken into calculation with the original data, whereas this one, it doesn't. All right, it's no good. Okay, so that's the first part you need to understand because they are going to test you on that on the regions. Okay, now second, you could do residuals by hand. So I'm going to go over this fairly quickly just so that you know where that come from because they're going to ask you to do this by hand on the regions, except they will give you this data. Okay, but besides, I mean, if you want to calculate a residual, all you have to do is subtract, because 4, right? 4 minus negative 14 is positive 10. 6 minus negative 2 is 8, so on and so forth. Right? So how do you plot a residual plot? Easy. Just plot the x and the residual. Okay, that's it. So for example, I should move this over here actually. Yeah, much better. Now, that means I gotta, all right, you know what? Let me shrink this a little bit. Oops, the answer's right there. Okay, that's not good. All right, it's okay. All right, so here. So let's see, let's use a different color. Okay, all right, so 0 is 10. All right, and then 1 is 8. Right, I'll do this real quick. 2 is 6. That's all you're doing, okay? 3, 4. 4, 2. And 5, 0. Right? 6. By the way, this is continuation. 6, 0. 7, 2. All right, I can kind of see where this is going already. 8, 5. And 9, 9. 10, 10. Yeah, that's awful. Right? So look, it forms a phi shape. So what does that mean? Right? The residuals form a pattern. So the line, it's a bad fit. Okay? It's a bad fit. Okay, all right. That's how you do it by hand. All right, so look. This is how you do it in the graphing calculator. All right, so let me go to the graphing calculator and show you. So here's what you would do first. So let me see what's a good, okay, here are the steps. So what I'm gonna do is I'm gonna actually just use one example and then we'll come back to class, okay? So, and we'll follow these steps that I listed out. This is also going to be in the manual, okay? All right, so classic example, all right? Or as we say in Latin, well, not we, all right? This is locus classicus. Okay, I don't know how to spell locus classicus. Okay, all right, so classic example, all right? So here, classic example number 1. Use the data to write the linear equation for the raw test score based on, right? And then they also gave us the residuals already. Okay. By the way, all this can be calculated with a calculator. All right, because the formulation in the calculator itself takes into account when you get a line, the calculator compares it to the raw test score and it automatically calculates the residual. So residuals is a function within the TI-84 calculator. Okay. All right. Now I'm going to enter the data in first. So now I actually clear the memory again. So let me go to stat diagnostics on, and then I'm going to go to stat and I'm going to edit this. Okay. So I'm going to press pause right now just to put these values in. All right. If you want to follow through, you can do that. Okay. So press pause right now. Okay. All right. So I enter in the data. I'm just going to follow through like we always do. Okay. So we're going to go to stat. I'm going to get the choice for Lin, right? AX plus B. I'm going to get the equation also. All right, because isn't that one of the questions? Yeah, they want the equation. You know what? Let's give them the equation first. How about that? All right, so let's give them the equation vars, y vars function y1 calculate. All right, so they want the equation. So let's give them the equation. So did they say round to the nearest hundreds? Okay, so 6.32x plus hundreds, right? Plus 22.10/100.43. There's our equation. Okay, what else do they want? Okay, they want us to create a residual plot, so we can actually plot it by hand. Okay, and then I'm going to show it to you on how to do it on the calculator. Okay, so let's see if this is 2 parts. If I can move this, of course I can move it. All right, okay. So here's what I'm going to do. I am going to make this transparent. Yep, look, super duper easy. All right, so let's see. I'm just going to do it like this. All right, so I'm going to plot it real quick. All right, again, I might edit and make this go faster. Okay, so let's see, where is it? 1 is 1.3, 2 is 1.9, 3 is negative 6.4, 4 is negative 0.7. It's like right here. Is that right? 5 is 2. 6 is 6.66. 7. Okay. 7 is. By the way, one of the things I want to assure you too is that on the regions, they don't give you that many numbers. So don't worry about having to spend like a huge amount of time entering data. Okay. Not only that, I mean, you know, with more data, you could make more mistakes too, right? So now, let's see. Based on a residual plot, this is what I'm asking. This is what I'm answering. Based on the residual plot, state whether it's a good fit. Yeah. Yes, because there's no pattern. No pattern to the residual plot, okay? Now, how do you do this on the calculator, right? So let's say you have to do it on the calculator. Yeah, there's nothing else to answer. Good, right? So take a look at this, all right? Pause if you need to. How do we do that, right? Second stat plot, change this to residual, and then it'll plot it for you. So watch this, all right? So second stat plot here, I'm gonna turn that on, right? Down here, I hope I'm still recording. Okay, good. All right, here I'm gonna change it. So how do you change it? You go second stat zoom. Okay, so second here. Second, oh, it's the list, right? I remember now. All right, so for here, when you're down here, second, by the way, I think you can see the keystrokes down here. Okay, second list, you see where it's reset, press 7. See how it changed to reset. And then now, if I graph it, it's not going to look that good. So what I'm going to do is I'm going to zoom 9. There's our residual plot. Okay, so now obviously we don't see the line. That's fine. Okay, because when we went for the residuals, it automatically told the calculator not to draw the original line best fit. So this is the look. It matches exactly like ours, right? Right here, right? This one here is exactly this. Is there a pattern? No, there's no pattern. So it's the line. So is this line? Is this line a good fit? You bet. And that's the lesson, okay? It's a little long, but okay. All right, I think we're good. Okay, so come back to class. We'll practice some more, okay? All right.
OMG, that was so good.